Alrighty, good afternoon, everyone. Thank you guys for being here today. We are joined by Dr. Savera Tanweer and Dr. John Brocklebank from SAS. And I'll just go ahead and kick it over to you guys, and if we have some time at the end, we'll open it up for Q&A.
Thank you. So I'll introduce myself a little bit more. I'm a technical architect in the Justice and Public Safety team here at SAS. I work with law enforcement, corrections, and also healthcare. John.
Good afternoon, everybody. I'm John Brocklebank, and I work in an organization at SAS called Customer Success. Do a lot of work with state and local government and other activities, and looking forward to chatting with you today on some new technology that we're embedding.
Yeah. All right. This is how our agenda will look like. We'll talk about the context, the motivation behind this work. Then we're going to cover SAS Viya Workbench, Snowflake, and we're going to also show some Python, open source programming, and unstructured data analysis. So we're going to go fast because we're going to cover a lot. John.
So we're going to talk a little bit about healthcare organizations and how the applications they provide and how they have some of the largest complex data assets that they have to deal with, and how they make decision making, how they interact with software. And the nice thing about this, we're going to show applications of using different aspects of SAS Viya. That includes SAS Viya Workbench, SAS Viya 4.0, and also we're going to show Snowflake. I'm working with a number of state and local government organizations that have access to Snowflake, so I'm very familiar with that technology, and I just want to show some examples using that.
So when we work with healthcare data, there's a lot of challenges. First of all, the data is siloed into different data sources, different systems with different formats, and it requires to extract, transform, and load it. It needs more, it's time consuming and requires a certain set of skills. Along with that, we need to make sure secure access and also ensure regulatory compliance. Other than that, it's coming from different systems, different formats. There's lots of missing data duplicated in different systems. So we also need to ensure data quality, prepare that data well for the analysis, because if data is garbage, you get garbage in, you get garbage out. So we need to really prep it and make sure it's ready for analysis coming from these different siloed systems. The healthcare data, it consists of private, PII, and sensitive data. So there should be methods in place to anonymize or mask that data, so that there's that concern also, because there is HIPAA and GDRC to protect all that privacy and security laws are there. Lastly, it needs to be automated. We need to make decisions fast and fair. So we need to have automation and near real time bringing in of that data. So what are the benefits that SAS provides in this space, right? So number one is it helps us make transparent, fair, explainable, and ethical decisions. So which means, how do we do that? So it has built-in bias monitoring and also explainable AI. So we can explain the data, we can explain the models and the predictions. Next, we want to benefit for efficient operational workflows and processes. So it has this all built in. You must have seen the AI lifecycle in a bunch of presentations earlier. So we can automate these processes, efficiently bring the data in, and then have this simple to use interface, which is a low code, no code interface, so that we can quickly build models. You can tune those and get the results and deploy them for efficiency. And that the purpose is to predict better and have cost reductions. And lastly, it's cloud native and cloud agnostic. So we support on-premise, hybrid, and in the cloud with multiple providers like Azure, AWS, Google, and so on. Over to you, John. Sorry, I didn't click through it. All right.
So what we're going to talk about today is actually a variety of applications. We're going to look at a database that we can access, and of course SAS can access all varieties of different databases. One customer I'm dealing with currently has their data in Snowflake. They have about 5 petabytes of data, of healthcare data. And we're going to talk about accessing that data. You can do that, of course, in VIA 4.0 with high performance analytics. You can also access it in via Workbench. I'll show you some examples of that. And of course, this provides a unified set of pipelines or activity for a variety of users. That includes programmers, data scientists, whether you're using R or Python or SAS coding. You can provide that as an integrated source. If you're a statistical programmer, a lot of times you'll learn Python in school, you learn SQL, you learn R, and so this provides an environment that you can combine all these together and optimize that delivery. And of course, we call sometimes end user citizen developers. The nice thing about VIA 4.0, it's a click and point environment. It's so easy, and we're going to see what Savera does with the environment and what I have to do in my environment to do an equivalent. So it's very, very interesting. So it blends in, everybody gives them the opportunity to develop. So Snowflake is just a database that you can use. It's high-end storage and query. It allows multiple accesses, high performance. Actually, for now in VIA 4.0, for example, some of the procedures will run inside Snowflake. So they're optimized from a scaling standpoint. And it provides seamless integration both in Workbench and also 4.0. Of course, SAS VIA 4.0, very high massive handles, very large data sets, distributed processing, allows for streaming of the data, transforming the data, supports unstructured data. It gives you, as I mentioned, it's not uncommon for people to have petabytes of data stored in this environment. SAS Workbench is an environment, if you're a coder, you have a natural tendency to jump on board with Workbench, and you can produce many different applications within Workbench, different solutions. And what I find that's interesting, for example, if you're currently in 9.4 and you go to Workbench, it gives you access to about 60 new procs and methods. And what I find too interesting is that some of the procedures that are working in SAS VIA 4.0 are available in Workbench. Under the covers, as you use the user interface, things like proc assess, assess bias, some of these procedures now are available in Workbench. Makes you pretty efficient in terms of scoring. So you can do visualization, and we're going to see some examples of actually running Workbench and doing some equivalent things that you can do in VIA.
All right, so we have chosen a very simple and easy to understand use case. This is basically understanding how lifestyle relates to diabetes and what are the risk factors. We have used a publicly available data set.
Yeah, this is a CDC data set that if you want to try out some things, it's available to everyone. It's a very clean data set. Unlike most of the data assets that we look at, this one is extremely clean, but yeah, it's fun from a standpoint of it has about 250,000 observations in it, about 23 variables, and binary target, whether you have no diabetes or you have perhaps pre or existing diabetes is the target. Then you have a number of drivers, BMI, for example, body mass, high blood pressure. You can see, we'll see a host of these in a minute.
Right. So I'll cover the SAS VIA platform, and I will be giving a little bit harder part to John here. But you must have seen this life cycle before. So we want to go from questions to decisions, and SAS helps you all the way through, starting from data management to access, prepare, and govern the data, which is coming from a variety of data sources, again. Then we develop models, we build them, optimize them, validate them, and deploy them, which includes automation, monitoring them over a period of time, seeing if any drift is occurring, do we need to retrain them, and that will eventually help us make the right decisions faster and on time. So the first step, as we said, is integration of data. Now we chose a simple data, it's a simpler data set, but in actual world, it'll be coming from different data sources, as we said. So we need to prep it up. We need to do anonymize personal information, do the prep, transformations, cleaning, all of that. Once we have data nicely prepped up, then we're going to develop models. And SAS, the good thing is it provides built-in bias assessment. So it's what I used was a low-code, no-code interface. So I just check this variable for bias assessment, and we'll get all these number of statistics to see if there was bias in data, and then what to do with it. We can mitigate it also. So we develop these models, and we can compare these different models. With a click of a few buttons, I can create random forest, gradient boosting, logistic regression, all these different models, select the champion model, and then pick that one and deploy it in Model Studio. And there it's going to be monitored over time and to see the drift, and also to keep assessing if it's still fair over a period of time. Now to VIA Workbench.
Yeah, VIA Workbench, those of you, for example, who are coding in version 9, like 9.4 and so forth, this is a instantaneous transition, for example. Gives you data access to any environment that you need. It's very quick to spin up. It's cost effective. You can spin up the environment, you can run your code, you can store your code there. You can then pull it back, you can modify it, it's very interactive in nature. Seamless deployment, you can change the size of your environment. And you'll have a lot of flexibility in terms of provisioning, scaling up and down as needed. And then, of course, you can optimize the cost, if you will, because you're only going to pay, of course, for the environment when you're using it. So it's cost effective from that standpoint, and it's real simple and easy to use.
Also I would just add, for like Python and R programmers, it is seamless to work on it because you get the Jupyter Notebook. So it's not much difference when coding in this environment.
And of course, it's supported by SAS. And of course, all the analytics, all the procedures that you need access to, all the enhancements, for example, are available within Workbench, in addition to SAS VIA 4.0. So it's an easy deployment if you're a coder. If you like to point and click, though, probably not a good candidate for using them, and you'll see that in a minute.
All right.
So the advantages, of course, R is now available. It was announced at Innovate, and it allows you to run Python, R, and you can have import projects. You can use Jupyter Notebook. Yeah. You can collaborate with GitHub for updated and versioning control of Python and so forth. And you can save these models as executables. You can create score code. You can run that score code, of course, and it becomes very optimized for deployment.
All right, so the first step we do once we bring the data in is exploring the data, like looking at that. Now, again, this is a very explainable example, and it validates what doctors and all these gurus have been saying for a while. What is most correlated to diabetic people? What are the risk factors? So we can clearly see high cholesterol is a risk factor. Blood pressure is a risk factor here. And difficult, like your general health, the patient's general health over the last 30 days, we saw that is also highly correlated with a person getting diabetes or not. We will talk about bias later, that do we see any differences in terms of gender or age, and our bias assessment will just show us that. But here we can see in just the exploratory analysis here that we see higher diabetes in higher age brackets, starting from 40, going up to 70 years, and we'll see the bias. And because of this, there will be some bias because it's naturally, that's how human bodies are. Again, here I'm showing how lifestyle is related. So does, eating vegetables or eating healthy, does it have an impact? We did not see that as a very big difference in the data, but we do see smoking a little bit, and then BMI. BMI is something that stood out. So people who are pre-diabetic or diabetic tend to have higher BMI. So that was one we saw. more clear, but the others, not a huge difference, we'll say. We'll see the same levels in both diabetic, and non-diabetic people. All right, so after that, I bring it into Model Studio, but this is Visual Analytics, because that also does the same thing. So it runs like decision trees behind this. It's an automated explanation. It's just, again, a click. So I drop, this is the variable I'm studying. These are all the factors that may impact it, and then it rates them. So you see general health, which is generally how a person is feeling over the last 30 days, followed by blood pressure, BMI, cholesterol, and age, highly correlated with diabetes. So for model development, well, it was an easy task for me. Maybe not for John. So all I had to do is I just put in, I automatically actually get the first node, which is data, and I just select the data set, and then I drop these different child nodes for different types of model. And they have some default parameters, and I can just run it, and it'll give me a model comparison, which I did, but we can always fine tune it. We can go into logistic regression. We can do interactions between variables, for example. We can do polynomials. We can do forward, backward. We can do all these selections, but even if you don't do that, you just put them, you just drop them, it'll still run for the first pass. And here is how I see it in Model Studio in the VIA 4 environment. So I can bring in that data set, and I can see these variables, and I can select which is our target variable. And then if you see here, I have chosen gender for bias assessment, and I've chosen age for bias assessment. There was no ethnicity in this data set, unfortunately. That would have been nice to see if it impacts ethnicity or not. Maybe in diabetes, not sure, but we couldn't do that. But that would be same way we'll have to do that. So once I run these models, what do I get? I get a plethora of statistics, results, comparisons, giving me a lot of information. So what this says is once you come out here and look into the insights, it'll give me a summary, and it'll show me which is the champion model, why it's the champion model, what statistic did they use. So they used KS for that, and it said logistic turned out to be the best. These were the most common variables across all models. And then again, what I showed you in my exploratory analysis, I can even see that in Model Studio, rating the variables that are impacting the target by their importance. And then parameter estimates. Again, you can see in logistic now I have interactions between the variables. So you see BMI up top, and you see age and cholesterol interaction up there, having a high T value, followed by heart attack, and again, age and cholesterol, age and gender. So giving you some insight into the models, how the variables are impacting the target, what combinations make the most difference.
I think it's fair to say, Severa, that if you had not included these interaction terms, the logistic would not be the best model chosen. How many people have seen logistic be their #1 model recently who have tried this? You have, okay, that's good.
Nice.
But in general, the more complexity you put in the logistic model, the better it performs.
Yeah.
I think that's a fair
But
statement.
otherwise, we regularly see gradient boosting.
Or forest.
Yeah. Meeting models.
But what do you like about logistic? It's very explainable, right?
Yeah. Very
The
explainable.
interpretability is key, and so that's the nice thing about it.
So another thing you get right out of the box is all these different types of score code for the path, for the node, for the training score code. You get the score inputs, you get these properties, different statistics, you even get the SAS output like you'll get in Workbench or 9.4, you get that as well. And then moving on to the bias statistics. But I'll just mention here, we can always take the score code and cheat in Workbench using that to develop models if you have both environments. So I think that's what John did to improve his models. So now we're looking at some of the bias statistics that has been talked in a lot of different sessions. We included that here. We see here, what this shows is like in terms of gender, there's not much of a problem. There's little bias, little bit of difference, but age, we do see performance bias as well as prediction bias. But I think it's expected for diabetes, but for other things, like if we are, for example, predicting recidivism, let's say, and ethnicity comes up, that is a problem. We don't want to base our model on race or ethnicity or things like that.
But you can look at these characteristics, the maximum predicted difference within a group. Those are all easily computable yourself if you didn't have access to that. And also true positive rates, you can certainly calculate those yourself. And you also have a procedure in SAS now called PROC-Assess, and you can get a lot of those type of statistics out of that procedure, which makes it easy. And you'll see that in a second.
You have a specific assess bias for this as well now in Workbench and Via 4. Again, age, now this is looking at bias for age, and we do see that range that we even saw in the exploratory analysis, right? So it tends to be, there's a bias for those age brackets from 40 plus, starting at 40 plus.
So you did one click on this, Severa, and got all this information?
Yeah,
okay.
I just did a checkbox and I get all of that.
So you got, like, if you go back a second, you go to the average prediction for the event. Real easy to calculate that from the output data set. Right. And this was running GenSelect, and you can actually get the code from VIA to see the code that's run if you want to modify that code.
Next, we're going to talk a little bit about Snowflake integration, John.
So here's a Snowflake access point. Looks very familiar. You can look at all your data assets within Snowflake. You can see information. You can drill down and access the data. That's really easily. And of course, in SAS Studio, you can access Snowflake with a live name statement. You can run proc contents, get the information you need.
But we use some macros to bring those in, right?
Yes, yes. And of course, this is SAS Via Workbench, and so I have a file called diabetes.sas that I can store and update and extract, and I can run proc contents on that data set. You've seen all that information before. It gives you all the variables, key information. If you're a coder, this is natural in SAS. If you go to the next one. Now, one thing we did have to do here, Severa, was we partition the data in such a fashion that we could have the same partitioning in SAS Via 4.0 and also in Workbench. So we wanted to be real clear on that.
Because if I don't specify the partitioning, the Model Studio will automatically do it for me.
Yes.
By default, set to 70/30, but you can change it.
Yes.
But we did it the same way so that we also verify and validate we get the same results, right?
Right. And so this, you created a CSV, I believe, with the partition variable on there, and then we just brought that in, and I brought that into Workbench, and then I did my proc contents on that data set. And so we had a fair game between the two systems.
And as you can see, John likes to work with all these different screens here with the code and the results. I can't work
to
like
blow
that.
it up. I have to blow it up. So there you go. All right, go to the next one. So there's proc contents, looking at my output, and validating. We validated the partitioning was all valid, and so forth. A lot of descriptive statistics just to character. There's a printout of the data set, real quick. And then what I wanted to do was make sure I could actually compute your model, develop the same model that in my environment. And so I ran proc GenSelect, which is the procedure. You can run logistic regression. It'll handle binary targets, nominal targets, ordinal targets. Very nice procedure. And you can parameterize it using GLM. So it took you how long to do that little flow?
Well,
2 minutes?
5 minutes?
This took me a little while. I had to code this and know what I was doing a little bit. So that the beauty of this, and there's a breakdown of the response profile. How many individuals were in the training validation, and for the non-event, the event, of course, is diabetes. And so everything matched up. Just to be clear, we wanted to make sure that we're comparing apples to apples.
That's right.
Okay, next run. So that was the assessment that that matched up. Everything was completely the same, and you get out of the procedure you get all the information statistics. You get AIC, and the smallest AIC I see is up there at for training, validation, and test. That's Akaike's information criterion, and you can do lift charts, calculate those yourself. Pretty simple to do those. Next.
But you had to write code to do that.
Oh, sorry. I had to write code.
It came ready-made for me.
Yeah. Next one. Sensitivity charts.
Go back.
And then what I did, if you go back, this is how you do interactions. In most of the modeling applications within SAS, you put a vertical bar, and then you put an @2 at the end of your variable list. And that says fit all main effects and all two-factor interactions automatically. So you don't have to code all those yourself. So you just put that vertical bar between them, and then I did a backward selection using the FAST method and created an output SAS data set and so forth. And this model, I believe, was a little bit better than yours. Sorry about that.
Right.
But so after I did my various adjustments and so forth, I created a smaller AIC than Severa. So I think I won a free lunch out of this.
But like, if I can bring it in SAS Studio in the VIA environment, I could do that too, but I was just too lazy to do that. I just wanted to tune in the parameters in Model Studio and then get done with it. So this was a little bit improved.
So this is, in terms of the bias sensitivity, I created my maximum difference. This took me an hour to create some of these bias statistics myself. Yeah. It's not that hard. So, and I know exactly what, I had a little coloration to this.
They're not as pretty like mine, John.
Yeah, I know,
But you get them,
but this shows you, this is prediction bias, average prediction for the event. So within each event, you have the probability of the event, you take the average within that. So a couple statements and a little bit of work. And make sure my code's right. Yeah, I got to QA my code, Okay, keep going. And there's the false positive rates by age. So there's definitely, you'd want to consider age as the potential for bias, and then you'd make an adjustment on that in a number of different ways. So I decided, let's go ahead and try the other methods. I went ahead and ran logistic. I compared that with forest and gradient boosting, and looked at a ROC curve, very, very close on all those models. Logistic had a slight edge as compared to the others. So, and there's as you can see, like the average square error, minimal difference in terms of logistic outperform. So, okay.
All right. So then I wanted to try out the Python modeling as well in Workbench. And I used the scikit-learn library, and I again did the logistic, the forest, and gradient boosting. But with the scikit-learn library in Python, gradient boosting was the winner. But I also didn't go ahead and change the parameters or code any interactions. I just wanted to see, how to do Python. Certainly, it was a lot more code than John wrote or what we used in Model Studio. But if you're coming from a Python background, there's not much of a learning curve. You just run it. And if you want to use SAS in the back end, you just up top change one one statement, and it will be faster, because this is slower than. And
it runs the SAS procedures behind the scene.
That's right.
And gives you what? The nice output.
Yeah. But it's still, the Python code is the same. Behind the scenes, it's running SAS. But this one is running the scikit-learn library, which I use, and it was a bit slow for me. Like, it took more time. But certainly you can compare libraries in Python and SAS, see which performs better in terms of number, maybe not the time. And with Workbench, you had that capability. You can scale it up or down if you want more processing. If it's taking time, you can certainly do that. And I'm getting the same statistics, accuracy, the average squared error. So it's around same what we got in Model Studio and in SAS and Workbench, very close.
The accuracy was better, wasn't it, on the gradient boosting?
Yeah, yeah.
And our accuracy in SAS logistic was better than
Yeah.
the logistic regression in Python.
But because we,
Yeah,
you know, we
it's
improved
apples.
it a lot. We
Yes.
included the interactions and all
Yes.
those things.
Yeah, we fine-tuned the logistic.
Yeah. Then I wrote some code to do these curves, looking at this, the ROCs for each, very close for all these different models. Looking at the confusion matrices for each, and we can see gradient boosting is doing well. But again, it's all Python code. If you're a Python developer, it's just very seamless. You go in, write your code, run it. Next, I'm going to talk about the model cards, which you might have heard before in this conference. Once you select the model and publish it and deploy it, this is monitoring it and auditing it over time. So these are like nutrition labels, looking at the model overview, the data, looking at the data overview. Let me play it. It's not playing. Okay.
And the
So
fairness.
this is a video because, yeah. Go
Yeah,
ahead.
yeah, and the fairness indicate, again, age is something we need to drill into. Over on the right, yeah.
Yeah. So you look at top, you look at, you know, that fairness, then going over the model uses, what is this model for? So they have these, this interface for everybody. It's democratizing AI, so anybody, data scientists, executives, risk managers, they can all look at that and understand the model that is in deployment and how well it is doing. It summarizes that just to get an overview of that. And you have same statistics coming from Model Studio, coming from information catalog about the data, the bias assessment metric, metrics that are also coming in. So we can look at that. And lastly, we have model audit, which is basically, it is looking at model over a period of time on the new data as it comes in when it scores, and if the accuracy falls down, then there is a need to retrain the model, right?
So this gives you the report you can give to your boss, right?
Yeah.
Yeah, it's all
or the boss
automatic.
can go in and look at it,
Yeah.
him or herself.
Right.
As well. Another thing that we just did to show you that this is also available, we didn't do it in a lot of detail, but unstructured data analysis. For that diabetes data set, I did not have patient narratives, so this is another data set. But a simple exploratory analysis, just dragging and dropping in visual analytics, can give you a lot. You can look at the topics in the data, so these are patients' narrative. And you can do a sentiment analysis. You could see a lot of it is negative, as you would expect, right? You can get, you know, what are the most common terms that are in these narratives. And then we can look at, you know, this is just showing the frequency of titles. So if you're analyzing the different disease, what are the patients in for, the different diseases, you can get this chart. So here, I mean, I don't really understand all that, but I can see, you know, some things are common. This, well, I can't even read it anymore, but some of these are showing that they were more frequent in the patients that were seen for this data set.
There is a proc you can even use in Studio or in Workbench called TextMiner. And that procedure will allow you to go ahead and look at word frequencies and create what they call a singular value decomposition of that information of word frequencies. And out of that routine, you can build synthetic variables that correlate with a target potentially. So you might have a binary target, you might have a multi-level target, and you want to know how these phrases or keywords or the asset of this data correlates with that target. And I've used that many times. I use that in the hackathon. One thing I found interesting too is when you're looking at malware detection, for example, the length of the URL sometimes correlates with the idea that this is malware. So even some simple things like the length of the text can correlate with the person filling in the form, for example. And so there's a lot of work you can do in this area that adds a lot of value.
You can develop text analytic models, which is the last thing here. We can write rules to define concepts, to define topics, and categorize that data. Again, do the sentiment analysis. So when this pipeline runs, it will give us different categories divided into topics and what was the sentiment there. So we can do all of that using text analytics in SAS as well, and can be coded also. John.
So this is kind of an overview, if you will. The beauty of it is you have the SAS underpinnings that gives you the high-end analytic values, the ability to automate some of this process, whether you go via 4.0 or you use something like Workbench where you code yourself and you integrate Python, R, and you compare results, develop a combined results. This allows you to do a lot of great things from an analytics standpoint. And the roadmap is, the only limitation is your imagination, basically, in terms of development. So, best of breed, I think SAS is definitely the best of breed, and you can drive to decision making quickly, scalable, and it allows you to tailor this environment to whatever your needs are in your organization and get results quickly. Quicker the way Savera works than the way I work, but at the end of the day, it comes to the same result.
You have the flexibility for
Yes.
all kind of users. All right, that was it. Any questions?
Go ahead, please.
Thank you very much for the awesome presentation.
Oh,
I have 3 questions. One, how do you anonymize the data?
can you hear?
Yeah.
I can't.
Can you hear me?
Yeah, I can.
Can you hear me?
No,
Okay.
but I'm going to get closer. So
So my first question is, how do you anonymize the data?
How do we anonymize the data? I can.
That's-
You want me to answer?
yeah, go
it?
ahead. And then
So,
I'll,
Should I run through all of them first? Okay.
okay.
Then 2, I was going to ask was, how do you measure the data accuracy if you're going to compare different models? But I think you touched on it. So the third question is, can you do PSM on the Workbench or the VIAS? PSM is propensity score matching, where you try to create a balanced data before doing the whole analysis, before doing the prediction.
yeah, that's an ETL process, right? Where,
So SAS has the proc PS match.
yeah, it's in via 4.0.
I don't use VIA.
It's in base SAS. So yeah, you could do it.
Okay, yeah,
Yeah,
you can
yeah.
do
So-
that.
but-
Yeah, you could do it in Workbench or then SAS Studio.
Okay. Could you have used education and income as a bias in the data?
We could. We did not do it because we didn't see a lot of difference there. But yeah, it could be done. We can pick any variable to do that. Sometimes it creeps in from income to ethnicities, right? But we didn't even have that ethnicity. So you could do that. Answering your first question, how do you anonymize? So if you have names, you just don't use them, or IDs. But there's also masking feature available. You can mask it, and VIA automatically categorizes the sensitive variables for you. So all those features are available for you. Thank you.
Thank you, impressive. I have a question, but I'm not sure about how you could answer it. Have you tried, or do you think we could incorporate genetics data?
Genetics data.
Yeah,
Yeah.
yeah.
You
Have you
could-
tested?
I've tested genetics.
Mhm.
I personally haven't, but it could be any
Yeah.
data that can be brought in, and it was just a simple.
Yeah.
Some models we use, but we can also use neural networks, deep learning. I think those are the ones more popular with genetics data, right?
I actually worked with a guy by the name of Bruce Weir. Have you ever heard of Bruce Weir? He was on the faculty. He was a geneticist at NC State. And we actually discovered the link between the ApoE gene and Alzheimer's many years ago. So yeah, I mean, I've been looking at that data for a long, long time. So, you know, it's at the end of the day, we ran these types of models and
Yes, it could
got
be
the connection.
customized, of course, for more use. Because what genetic data I'm referring to, it's a whole genome sequencing data.
Yeah.
So it's a big files, big information, and we
Yeah.
need to prioritize what's outcomes could come from these data, that it could make sense with the combination of all the
Other types
parameters.
of data.
Exactly.
Yeah, absolutely.
We were using SNP data. Yeah, we used SNP data and correlated that with ApoE gene, got the area of the SNPs and correlated that with Alzheimer's or not. About 20 years ago, sorry.
All right, thank you.
It was a really great session. I just have one question. So if I wanted to add my own code, let's say between two nodes, would I be able to do that?
What is your code? Is it Python or SAS?
It could be
Yes.
SAS code.
Yeah.
Yeah, you can put
yeah.
a source code node in.
Source code.
Oh, okay.
Yeah. You can
Child.
do that in Model Studio and
Yeah,
Workbench.
child node.
Okay.
Yeah.
And do you also have the explainable models as well in this interpretable models?
Yeah, I think the statistics we showed that explain what output comes out of Model Studio
Yeah.
tries to explain why it's the
Right.
winner model, what were those variables.
The range of the, of the predictive value, the average, there's all those things for prediction bias and parity bias. Yeah.
Yeah.
They're easy to compute, by the way. It's just work.
No.
Takes some time.
I meant like the Lime models or SHAP, those.
Do we get Lime statistics?
I'm not familiar with that.
Well, I think I've seen them. I've not used them, but
No.
you should be able to.
Oh, okay.
Yeah. How are you computing them now?
I'm not using it right now, but
Okay.
I might be using it.
Yeah.
Okay.
I'm
Yeah,
sure.
we can get in touch later, and I'll try to find
Oh,
how to
Yeah.
do that. Yeah, but we didn't do that in this one or
Yeah,
others,
yeah.
but I'm sure.
that's great. Thank you.
Thank you.
Thank you.
So I saw the narrative being input in there. When there's like common abbreviations for something or that basically mean the same thing, can you guys group those
Yes,
abbreviations?
yeah, when
Yeah.
we specify those, when we topics, there are rules to do that. So in NLP, you can create all that. Like I worked on child sexual exploitation data, and they need to find out grooming in that data. So you can specify rules like, what is this person asking to meet there or something. So you can create multi-level rules even to do that. Abbreviation is probably simpler, just putting it in there to identify those, or names or places and addresses. Yeah, that's right.
Thank you.
Thank you. All right. Thank
Great.
you.
Thank you very much.
you.
Appreciate it. Have a good day. Enjoy the conference.